What is light? You may know that it's the fastest moving thing there is, or that it consists of both particle and wave properties. Or maybe you only know that white light changes to a rainbow of colors when refracted in a prism, like it is in Pink Floyd's The Dark Side of the Moon album cover. There is a complexity to light with many factors that hardly seem realistic, and a simplicity to light that is all too often taken for granted. Light is a defining aspect of human reality. It is the reason that humans have the ability to perceive anything in the surrounding universe. To understand why this is true, we must first understand what light truly is. However, history shows that this is no easy task. The 5th century BC was the first recorded time that anyone truly attempted to explain the nature of light. It was Empedocles, a Greek philosopher, who postulated that everything was composed of 4 elements: fire, air, earth, and water. He believed that the Greek god Aphrodite made the human eye out of the 4 elements, and that she lit the fire in the eye which shone out from the eye, making sight possible. He proposed the theory that an interaction took place between rays from the eyes and rays from a source such as the sun to accommodate for the lack of visibility in the nighttime, and people generally accepted this for 1500 years. So until the year 1000 AD, people accepted that light was simply a product of the eye, as if it didn't exist unless people were observing things. It was eventually proven that light was not, in fact, a product of the eyes. And after much analysis over the years, it was found that light is only a small portion of something much bigger, called electromagnetic radiation. Electromagnetic radiation is energy in the form of electric and magnetic fields that move through space as waves. A wave can be defined as a disturbance of particles that transfers energy from one location to another. Sound waves, for example, are a disturbance of particles in the air. The air particles bounce into other particles until all the energy in the sound wave has been dissipated. The intriguing part about electromagnetic radiation is that it needs no outside particles to disturb for it to travel. In other words, it needs no medium for energy to be transferred. This is the reason that visible light, which is within the electromagnetic spectrum, can travel through a vacuum, which is essentially nothingness, while sound cannot travel at all in a vacuum, thus nothing can be heard in space as there are no air particles to be disturbed. However, electromagnetic radiation does exhibit properties of particles being disturbed, particles which are called photons. It is important to note that these photons exhibit both particles and wave properties at the same time. This is known as the particle-wave duality of light, one of the main concepts in quantum physics. More on that later. Photons are the energy that is being transferred from one location to another in electromagnetic radiation. But photons are massless, allowing them to travel faster than anything at speed c, the speed of light, 299,792,458 meters per second in a vacuum. Electromagnetic radiation consists of a wide variety of energy in different wavelengths and frequencies, which are organized by what is known as the electromagnetic spectrum. This spectrum is categorized into 7 different radiation types, with light making up the smallest portion of the spectrum and being the only portion of the spectrum visible to the human eye. It would seem that humans just happen to have the ability to see electromagnetic radiation in this portion of the spectrum, but it makes sense from a biological standpoint, seeing as light propagates well in water, where life on Earth originated in, and the sun emits huge quantities of radiation in the form of light. The many wavelengths of light are what the human eye perceives as color. Natural light, which is light from the sun, consists of all the wavelengths of light, all the colors, appearing as a white mirage. When natural light shines on an object, some of the wavelengths are absorbed by the object and some of them are emitted. The wavelengths that are emitted are all the colors that define the object. This happens because light is essentially energy, and when directed at an object, the electrons within the atoms of the object become excited, meaning they move, oscillating in between the orbitals of an atom. When an electron is struck with the energy from light, it gains potential energy when it moves in between orbitals, then emits that energy at the wavelength of electromagnetic radiation that defines the color of the object. Because the energy electrons absorb and emit depends on the orbitals of an atom, and the orbitals of an atom depend on the element the atom is classified as, alike elements absorb and emit the same wavelengths of light. This is known as the absorbance and emission spectrum of a substance, which is used for discovering the identity of the elements in matter emitting light. This is especially significant to astronomers observing distant bodies because they can use spectroscopy, the branch of science concerned with the interaction of light and matter, to determine the substance of an entity. As I have said, there are some aspects of light that hardly seem realistic, and one of these is the speed of light. In the 19th century, renowned physicist James Clerk Maxwell had set out to discover the velocity of Earth's motion. He did this by shining a ray of light in the direction of Earth's motion and another ray at a right angle to the first ray, assembling an apparatus that would reflect the light rays back and allow him to record their speeds. This was a valid experiment to perform, as the speed of light was known by this point, and if one ray of light was in the same direction as the Earth's motion, then that ray should return before the ray at a right angle to the ray of the direction in Earth's motion. However, the results of this experiment were incomprehensible. Both rays returned at the exact same time. There was no explanation for this until renowned physicist Albert Einstein published his theory of relativity in the following year, which is based on the remarkable suggestion that the speed of light remains constant for all observers independent of their relative velocities. Soon after his theory of relativity, Albert Einstein discovered the photoelectric effect. The importance of this discovery is that it proves that light is made up of particles, but there was already evidence that it consists of waves. This is where the particle-wave duality of light comes from, and it is the fundamental basis for the modern branch of physics called quantum mechanics, which is defined as a theory of matter and energy based on the concept of quanta. The concepts that make quantum mechanics so difficult to understand include Heisenberg's uncertainty principle, which states that there is a limit to the precision with which the position and momentum of a particle of light can be known. And Niels Bohr's theory that not only does electromagnetic radiation have a wave-particle duality, but so does all matter. However, both cannot be observed at the same time. This strange idea that light and matter both have particle and wave properties, but can only be observed as one of the two at a time, is called the Copenhagen interpretation, which states that light travels in waves, but when it is observed, it collapses into particles. With this understanding, it would appear as though the observer affects the way light behaves, and it appears as though the phenomenon of light becomes something of a philosophical matter rather than a scientific one. Let us go back to Empedocles, the Greek philosopher with the first theory of light. Remember how it seemed ridiculous that people could only observe things because they were looking? Well, that's the current theory of light and matter. When considering the theory that photons and all matter have particle and wave properties, but only exhibit wave properties when there is no observer, one must wonder, does the universe only exist because there are intelligent beings to observe it? Even Einstein could not fully believe such seemingly science fiction concepts, stating, "I can't accept quantum mechanics because I like to think the moon is there even if I am not looking at it." Light being the defining factor in how humans interpret reality completely distorts the traditionally held scientific understanding of reality and of what is possible, but it always is plausible that there are aspects regarding light that have yet to be discovered and may be the key to understanding the odd modern concepts the light is structured upon. The speed of light is completely instantaneous to the human senses. Everything that humans perceive is merely nanoseconds in the past, and on top of this, it would appear as though things don't even exist unless there is someone to observe them, and it's all based upon the phenomenon of light.